Okay, second day of section 12.1. We're going to work with the piecewise functions today. We don't need to redo the definition of a limit. That's not going to change. Let me put some notes here for the piecewise functions. We've graphed these before, but that's all we did with them. So this first part will be review. I will show you one new strategy with the graphing calculator today. So to graph, we're going to use your prior knowledge, tables, and or graphing calculator techniques. All right, so let me demonstrate with number one. I remember piecewise just have domains. So we want to graph the function first, and then once we have the graph in front of us, we'll decide if it has a limit or if it does not exist. But we need to get a good quality graph first, then we'll answer this question about it, okay? All right, so just a couple notes over here off to the side. So to graph, let's make sure we know what we're doing here. We're going to break this up into two steps. I'll just follow the first line, right? All I have to do is follow this top line here for my function. So I'm going to say step one or line one is going to be y equals x plus 5. But only when x is less than -2. Okay? So just read them one at a time. And then the bottom line says y equals x squared minus x under that condition. So my second graph will be to focus on x squared minus x, but only when x is greater than or equal to -2. Restricted domain functions. Okay? Okay, so here's one way we could do y equals x plus 5. We could just use some prior knowledge of y equals mx plus b and then just realize where the cutoff is. Okay, once I get that going, then I'll also show you the table. I'm not going to do a scale too like they have here, so I'm crossing that out. It's up to you, but that's going to throw me off a little bit. And I don't think we need the extra space. So each of these are just going to be a tick mark of 1, scale of 1, okay, is what I'm going to use. I encourage you to do the same since you're going to model what I'm doing. Okay, so prior knowledge, y equals mx plus b. So I'd start at 5 with my y-intercept, and then it has a slope of 1, right? Up 1 over 1. So I could go up 1 over 1. But if I keep going that direction, it's the wrong direction because my graph exists when x is less than -2. So I'm going to go down 1 to the left 1. Okay, to get some other coordinates. I'm just lightly getting some coordinates going so I can graph a straight line. Okay, so there's y equals x plus 5. On normal circumstances, I'd be graphing all the way through like this, right? Okay, but I don't need that entire graph. It's only supposed to exist for x values less than -2. Don't jump to -3. We still need to include -2.01 and all of that. So we still start at -2, but we need to start with an open circle. So when x is -2, which is right here, this graph is going to start here. So I'm going to erase that, put an open circle right here at that coordinate and going this way. Okay. The other graph, part of the graph to the right, I don't need, right? So I'm going to go ahead and get rid of that now. Don't need it. Okay. Hopefully that makes sense to you. There's the prior knowledge I was talking about. Y equals mx plus b. I just drew it, and then I chopped it off where the domain is asking me to. Open circle. Okay, another option is to make some tables. So here's the table approach. We definitely want to use a table for step 2. So here's the table. Okay, for y equals x plus 5, here's an option. Okay, just watch here for now. I just do y equals x plus 5 and go to my table setup and maybe start at the -2 and just change the table back to 1s. Okay, so what I could do to create a table for this, let me set it up on paper first. come up with x values that are less than -2. I always want to start at -2 though, right? I need that beginning point. So at -2, maybe just do -1. I'm sorry, less than -2. Let's go the other direction. -3 and -4, okay? So what are some corresponding y values? Like I said, if you throw this in your table, we can get those really quick now. So there's -2, I have 3. -3, I have 2. Okay, I'm just going to write those down. So -2 is 3. -3 is 2. -4 is 1. And what could I do? I could go over and plot these now. I just got to remember it's open circle. Maybe even make note here. It's supposed to be open circle for this one. So a -2, 3. There it is, coordinate. -3, 2. It's already on my graph. Okay, so we could also plot those points and do it that way. You pick. I'm trying to give you options, whatever is going to click for you. Okay, now here's one more technique I could show you, which is kind of cool. It's going to be really neat for number 2, is you can also tell the calculator these restricted domains. Let me show you how we do that. If I go to my y equals, your function has to be in parentheses. So I'm going to do x plus 5. And then next to it, I'm going to put the condition in parentheses. So I'm going to hit x again. And to put in an inequality, we go to this test feature right here. So if I hit test, and then it's supposed to be less than -2. So I'm going to choose the less than, number 5, -2, and now graph. It's kind of sweet because it just chops it off for us. There it is. And now if I go to my table, it's also going to give me those coordinates right away too. Anything above -2, it doesn't give me anything because we want it to stop there. So that might throw you off on the starting point. But anyways, maybe you should do this. Here's a fix to that. I could go back here and do less than or equal to. That way it'll give me that coordinate at that spot, and I just have to know it's open circle, okay, at that spot. So now I go back to my table, and I can actually see the value at -2, which is 3. Okay, so use that option too. There's 3 options. Choose one and figure it out and get it right, okay? All right, so that was 7 minutes on a linear function. Hopefully it'll go quicker now. All right, how about the quadratic? X squared minus x. Your prior knowledge of just knowing how to graph this is going to be rare for quadratics. This one might be a little bit easier. This is just a vertical shift down 6, so that might be easier to use your prior knowledge. But for this one, I definitely jump right to a table or graphing calculator techniques. So let's set up a table for this one. Y equals x squared minus x. What are some values I'd be interested in? Go ahead and write that down. Values that start at -2 and are greater than -2. This is going to drive my table. So -2, -1. I think once we see the graph, we're going to realize we need a couple more coordinates. But that's just from using the graphing calculator, and we'll see that. Okay, so let's use that restricted domain feature now. Y equals, I'm just going to get rid of this now. I could put it on the same window, I guess. Let's just stick with one. I don't want the multiple tables to mess you up. So let's go x squared minus x. And then close the condition. X test is greater than or equal to -2. Okay, and look at the graph. Look what it does this parabola. Starts it at the correct spot. Kind of cool, huh? All right, so I told you we need to go over a little bit to get that bend. Let's try to get the bend of all of these parabolas. So let's just go to the table and put them down, and then just plot them, and we'll wrap up this problem. So if I go to table now, at -2, I have my starting point of 6. I'm just going to throw it here now. -2, 6. -1 is 2. 0 is close to the origin. And then at 1, it's 0 because it's turning back up. I'll add one more. 2, 2. Why not? Okay, so let's plot these. -2, 6. Close circle because of the line underneath the inequality. -1, 2. 0, and then 2, 2. Okay, so the parabola was coming down here, and it just dipped just below this spot because it turned like that. Okay, so there we go. We just got to get comfortable with the tables and the y equals. I'll give you some time to practice that. And so now we can answer the question. The limit of this function as x approaches -2. So look, from the left, I have a limit of 3. From the right, I have a limit of 6. They're not approaching the same number. So when that happens, we say does not exist for the final answer. So this problem will be worth 3 points on your quiz. Point for this graph, a point for this graph, and one final point for the correct limit answer. Okay? All right, you tried 2. Once again, now you got an x cubed. I definitely want to encourage you to use this table feature. The 3 minus x, you might be able to get by with your prior knowledge, but you can also use the calculator for that too. All right, your cutoff now is at x equals 1. Over here, I'm going to change the scale again, so if you want yours to look like mine, I'm just going to use the tick marks of 1. Okay? So give that a try, and I'll give you some feedback. Here we go. Here's the x cubed. Remember, the x cubed function kind of looks like, kind of turns through the origin. That's the x cubed. Plus x affects that a little bit. But anyways, here it is. Here's what I plugged in the y equals. I put greater than or equal to 1, even though it says greater than 1, just so I get that beginning point. And you just got to remember it's open circle. So now I go to my table, and at 1, I can grab 2 now. So I plot 1, 2. All right, next one. It accelerates pretty quickly. It's at 210. So since I changed the scale, maybe you didn't change the scale, I did. So I'm a little off. I just put 210 up here, and it's got a little bend to it, but it almost looks like a straight line on your graph pretty much. Okay, so there's that one. And then you can use your graphing calculator for the next one, but I didn't just because it's just mx plus b again. So I'm starting at 3. I have a slope of down 1 over 1, so I went down 1 over 1. Now this one's closed circle, but when you have a closed circle on top of an open circle, it's just going to appear closed. So, and then it's going this way, right? When it's less than or equal to 1. So that's the graph. Okay. All right, let's try one more here. Let's take a look at 3. 3 has a horizontal line, so let me get you going on this one and then let you finish it. Okay, back when I first taught piecewise graphs in the first semester too, I kind of gave you a cutoff line. All right, so this is going to be my line of 2 right here. So your cutoff line, if you want to kind of start a little barrier to help you, no, one's going one direction, one the other, go ahead. Just another strategy. Okay, so remember, one graph is going to be y equals 5 under that condition. X is less than 2. And then my other one is y equals 2x plus 1. Okay, under the condition x is greater than or equal to 2. Y equals 5. That is always a horizontal line. So 2, making this 4, making this 6. So y equals 5, if it didn't have any restrictions on it, would be a line going right across here. But it's only supposed to exist when x is less than 2. So I'm going to start with an open circle right here at the x value of 2, going this way, like that. Okay, so that's how we do the horizontal line. All right, you go ahead and finish the other one, then answer the limit. Oh, we didn't answer the limit in the last one. Go ahead and finish that. Answer the limit question, and then we'll also talk about the limit question for 2. You can answer that as well. Okay, so I just started at 1 and went up 2 over 1, up 2 over 1, up 2 over 1. Okay, because this graph has to exist over this way, to the right of 2. Now it's a closed circle, so I'm going to fill in that closed circle over top of an open circle, and there's the next coordinate I need to draw that line. Okay, I don't really need that coordinate there. So there we go. Now the limits of this function as x approaches 2, it's converging on the same number. So when it converges on the same number, it does have a limit. It exists, and it's going to be 5. So that's the answer to that limit. Okay, whereas the last question, number 2, was 2. It approaches that number of 2 there. Okay. All right, your assignment will be number 4, and then the next 3 problems on the next page. I'll post that online. But this problem 4, the next 3 problems. Okay.